All right, all right, all right. Here we go. We're going to tackle this problem, think through it. This is my motto. Here we go. We got this. We got this. So we saw the demo, right? So you got 110 grams on one side and 100 on the other. We're going to draw out the forces. So here I have a weight force. I'm so sorry. I don't know how to draw straight lines. It's a weight force based off of the 110 guy. And here I have a smaller weight force, okay, based off of the 100 guy. So they're not the same, okay. I also have, let's be honest here, I also have tension going upwards, okay. This tension will be less than the weight on the right, and then there'll be a tension here, and this tension will be greater than the weight on the left. But those two tensions are Newton's third law of force pairs, and those will cancel each other out. So they're equal to each other. So if you look, the unbalanced forces for my system are these two. So if I go F net for my system equals MA, I have my masses involved. I've got 100 grams, so 0.100, plus 110 grams, 0.110. Okay, my net force is the weight of the big guy minus the weight of the little guy. So we're going to plug in some math on that. So that's mg minus mg, okay, equals 0.210 times A. Okay, but now let's plug in my m's. So my mass is 0.10 times g. I'm going to use 10. Let's make life easy. Minus 0.110 times 10. And so I get, it's all good, Lemberg. Are you taking yourself? Yeah, I know, but still say hi. It's okay. Going backwards, I would have the bigger one first. So I just wrote those backwards. As I'm plugging it in, I would have that be, let's rewrite this line. So this would be the big one minus the little one. And so it gets 0.11 times 10 minus 0.1 times 10 and then divided by 0.21. So I get an acceleration of 0.48 meters per second squared. Okay, so there we go. Cool. The other big one is, we're not going to calculate it right now, but I want to talk conceptually. That blue arrow, that tension, the left side one has to be more than the weight. The right side one has to be smaller than the weight. When you want to solve for what those tensions are, what you do is you go and look at one of them. So F net equals MA for one of them. So the F net is his weight force minus the tension for the right side guy, and just use the single mass. But look what you solved for. You had solved for the acceleration. So the key to these problems is you start with the system. You think, okay, what is it that's accelerating my system? And the second thing you do is you go, what mass is being accelerated? Okay, use those pieces of information, and then you transition to go, okay, now I'm going to look at individual objects. It just depends on what the question's asking you. So there we go. All right, guys, keep going. You're doing good.